what it actually allows you to do is allows you to verify computation of a thing without showing you any details about what was actually computed, which is extraordinary. We really foresee a lot more interesting applications coming out of this as well, something that I don't even believe like you and I in this podcast will be able to imagine, and that's good. Like our imagination should not be the limit of what can be built. What we build right now is basically limited by what's possible on chain. This unlocks access to information. Any finance guy will tell you the more information you have, the faster liquidity moves. The more money, the more opportunities, the faster the price grows and everything. So we really want to like unleash that for the ecosystem.
Welcome to the Edge Podcast. I'm DeFi Dad here with Nomadic. Today's show features the CEO of Boundless, Shiv Shankar. One of the most talked about technologies in our space is referred to as zero knowledge or ZK. And today's episode is all about bringing ZK benefits to the likes of an Ethereum L1, as well as other L1s and L2s.
Yeah, a few things we cover. We kind of go back to the basics just to kind of traverse, okay, like what is ZK? Why does it even matter? And then we talk about, there was this idea that ZK was still pretty far away. And Shiv even talks about this himself. But ZK tech is here now and becoming more and more usable every day. And I think we kind of get into how it's just crushed everyone's expectations of when it would be usable tech.
Yeah, and with ZK, it feels like the technology that sort of solves all of the lingering issues we have in Web3 or in DeFi and crypto. So ZK tech can help to address challenges with privacy, identity, security, and I think one of the main benefits we take a bit of time to talk through at the very start is what it means in a post-quantum computing world.
We also talk through how this ZK tech looks like it's going to be a foundational pillar of scaling Ethereum. And we talk through how this directly relates to RISC Zero, their involvement with the EF on kind of pushing this forward. And yeah, we get into all of this.
I think for all of the DeFi that we normally cover, this is an episode where we take a step back and kind of go back to our roots and just understanding the tech stack that enables all of the things we enjoy most about DeFi. So there's no doubt if this tech can proliferate, we as DeFi users are no longer going to have to worry about limitations of throughput. We're not going to have to worry about liquidity fragmentation with all of the different like L1s and L2s that you might use. So there's lots and lots to celebrate here with all that's being built.
So almost as early as I can remember, ZK's just commanded such mindshare within our space. And I almost thought it was like more of a crypto phenomenon than anything. But Shiv kind of talks us through how it's once again escaping back outside crypto and into mainstream industries like cloud computing, AI, finance. And looks like it's finding its way into kind of the bedrock of those industries as well.
So before we get started, just a quick reminder, you can subscribe to the Edge podcast and the Edge newsletter by going to the-edge.xyz, the best place to get real-time notifications for new podcasts and new Edge newsletter posts. You can also subscribe at our link tree. It's edge_pod. That's where you can subscribe to our Spotify channel, Apple Podcasts, and YouTube. And then just a quick shout out to all of our sponsors. Thank you to those who are making all of our content possible. All of our content is ungated. All you have to do is subscribe with an email at the-edge.xyz. And again, that is thanks to the support of all of the awesome sponsors we have in the show notes. So be sure to go there, check them out, click on the links, and learn a bit more. Grow wealth exponentially. With TOROS leverage tokens, when the market moves in your favor, your gains become parabolic. They're built to ride trends, auto-compounding profits. With TOROS, it's simple. Pick a vault, deposit, and your exposure is multiplied, maintained, and protected automatically against liquidations. TOROS reduces risk and keeps you in the market ready for the rebound. When markets dip, the vaults auto-adjust, softening losses and preserving your position. Just pick a token to multiply your returns. TOROS Finance, exponential gains with leveraged tokens. To learn more, go to toros.finance. REDSTONE is building the Oracle backbone to unlock real-world finance on-chain and next-gen DeFi. With modular gas-efficient feeds across over 110 chains, trusted by 170 clients, supporting over 1,300 assets, from value-accruing stablecoins, liquid staking and restaking tokens, to treasuries, private credit, and commodity tokens, REDSTONE delivers accurate real-time data where it matters most. The biggest platforms and protocols in DeFi today choose REDSTONE oracles, such as Athena, Securitize, BlackRock Biddle, Pendle, Spark, and Maple Finance. If you're building the future of finance on-chain, you need REDSTONE's leading modular blockchain oracle layer. To learn more, go to redstone.finance, and thanks to REDSTONE for supporting us here at the Edge Podcast and Edge Newsletter. Maple Finance is one of my favorite products in DeFi. It is a gateway to sustainable real yield powered by over $1 billion in AUM across USDC and BTC products. And now with SYRUPUSDC by Maple, anyone can earn institutional-grade yield. Learn more at syrup.fi, and thanks to Maple for supporting us here at the Edge Podcast and Edge Newsletter. FALCON Finance, the team behind the fastest-growing synthetic dollar, with institutional yields that are competitive and sustainable, offering yield optimized across your favorite DeFi protocols. Point season is now live. Learn more at falcon.finance. NEUTRL is the next generation of crypto-native yield. Their synthetic dollar NUSD taps into OTC arbitrage, funding rate inefficiencies, and delta-neutral strategies to deliver premium, stable returns without taking market direction risk. NEUTRL is currently live in private beta and will be opening for public deposits soon. Learn more at neutral.fi. All right, let's introduce Shiv Shankar, CEO of Boundless. Shiv, welcome to the Edge Podcast. How are you doing?
I'm doing great. Thank you for having me.
So we're very excited to talk to you all about Boundless and RISC Zero today. I know as a longtime DeFi user that it's very important, the tech that you are developing. It's important to privacy, identity, security, and most important, most top of mind nowadays, a post-quantum computing world. So we're going to get into all of that here today. But Shiv, can we start with RISC Zero? Let's talk about what is RISC Zero, what has RISC Zero been building, and how does this all relate to Boundless?
Yeah, that's a great question. In fact, it's a great story. I think marketers would call it narrative, but it is actually a really good story of how RISC Zero got started and how we ended up here. RISC Zero was founded in Seattle with three founders, Jeremy Brewster, Brian Redford, and Frank Laub. A few years ago, I think Jeremy and his friend, they were wrapping up their previous startup, which they had actually sold to Intel. And Jeremy was trying to find his next big idea. At some point in time, I would like everybody to meet Jeremy because he's one of the most interesting people in the world. He taught himself, he never went to college, taught himself all the mathematics and computer science in the world. So much so that he's advancing the field, sort of like, Matt Damon from that movie. And he was just reading papers. That's what he does. And one day he reads this paper by Eli from Stocknet. And I think the story goes he's in his bathtub, not necessarily doing all bathtub things. And he reads this paper and he has this thing. He was like, oh my God, this is going to be the next big thing. And he runs to his friends the next day. They're at a bar somewhere. And he's like, you guys, we need to learn more about ZK. It's amazing. It's sort of, completely revolutionized everything. And they're like, okay, cool. But how do I ZK? What is it that I do to write a ZK program? It's like, oh, you need to write circuits. So that has been the state of ZK for the past sort of 30 years. Studied in universities, there's applications in high-end finance, in military research, in very specific use cases. So there's maybe 200 people in the world who can write circuits, another 200 people who can audit circuits, and these 400 people just sort of have a little industry of their own. Nobody knows anything else about ZK. And that's when Jeremy realizes that ZK is unbelievably powerful, but it's not accessible to even the best developers that he knows, his friends, particularly one of them becomes the CTO, of course, Frank. And he realizes, okay, this needs a little bit of a think. And because of his background in mathematics, in hardware, in computer science, in quantum computing, in all of it, he puts this together that like, oh, what I need to really solve is this DevX problem. How do I actually empower every reasonable dev in the world to write ZK programs? And that brings forward the ZK VM, and RISC Zero invents the ZK VM. What it actually allows the regular developer to do is either you learn Rust or you know Rust, and you can write a regular Rust program that gets compiled into a circuit. And that means anybody who knows Rust is now a ZK programmer, which is great. And that's when we ended up on the map. And I think there's a famous quote from Vitalik, which is like, who is RISC Zero? Because it starts hitting the news. And because this is the domain of high investment. Polygon famously spent $200-300 million acquiring every ZK researcher on planet Earth to write one circuit, the ZK EVM circuit. The ZK VM promised to like change that completely, and it did. We wrote our EVM circuit inside the ZK VM with 2 devs over 2 weeks. They took 3 years and $250 million. So the order of magnitude difference was like unbelievable in terms of DevX. But ZK has always had like a few problems with it. One of them notoriously is speed or performance. What would take like a few milliseconds or microseconds on a regular computer would take hundreds of seconds to run with the ZK setup or on a ZK circuit. A lot of people had this doubt that, okay, the ZK VM probably made it very easy for people to write ZK programs, so probably slowed it down even more. But that's the magic of platformization. Something that if you are a system developer developing operating systems or database systems, you're actually very familiar with this, is you actually layer, some people will call it modular or like, whatever the term is, you start layering your system. On the operating system, you would have like, file system, networking and all that stuff. The reason why generally architects do that is now you can attack the problem in parallel. And that started happening. The ZK VM became much faster than handwritten circuits in a lot of cases because we made the hardware layer go faster. The integration between the hardware and the software layer became more optimized. The software layer became much better written, as well as the mathematics of it kept improving. So we started seeing 3 to 5x gains per quarter, and all of this compounds. And today we are extraordinarily cheap, especially when put on a network like Boundless, and extremely fast and efficient. So much so that it is now consistently cheaper to run your computation off-chain and pay for it to approve a network rather than run it on-chain with like gas costs and such. So one thing the story goes all the way up to the ZK VM, which is great. Now you have a ZK VM, it works, it's functional, it's fast, everyone's interested. The next question is, how do you get it into the hands of customers? Therein lies the distribution problem. And I was explaining this as well, I think, earlier before the call started. Seattle is a cloud city, home of all the cloud companies. The way you actually build a cloud is you talk to customers and listen to them. So we started talking to a lot of customers. So you're like, how would you like ZK delivered to you? Would you like it as a binary that you can run locally in your data center? The answer is no. Nobody wants to run anything in a data center anymore. How about we put it in the cloud and give you a RESTful API? Would that work? We tried that even. And they said, okay, that's cool for us to play around, but we can't run this in production. We can't take a central dependency on you. So that takes us back to the whiteboard. And we wanted to design something that customers like EigenLayer and, L1s and L2s, Ethereum, Arbitrum, Optimism, anybody could use and depend on without any fear of like, oh, if the Steam vanishes or if they run out of funds or something happens, that the network would go down and that would impact their performance and their customers. That's what we ended up designing, which is Boundless. A completely decentralized, permissionless, universal ZK protocol that brings ZK to every chain. A sort of analogy that people can use is how Chainlink brings oracles to every chain. We bring ZK to every chain. In your own native dev experience, if you're a smart contract developer, you're just calling out the smart contracts. You're not learning new things about ZK. You're just running a program, paying for the cost of that program, getting the results, and just like running with your regular life. So that's really the goal of Boundless. I'll hit pause here. Well, I don't want to like keep on going.
Yeah, so much there I want to dive into, but I think listeners and probably myself selfishly want to just take a step back and go back to basics here just a little bit, because we're talking about ZK, we're talking about bringing it to blockchains, but I think it's just worth a quick primer on ZK. Like what is it? Explain it at a high level, and then I'd also just like to know, like, what's the fundamental constraint that ZK is really solving for? Why do we need it? Why should people care?
Yeah, so that's a great question. So ZK is ZK, or verifiable computation, as the field is more broadly known, was studied in universities as a security product. So if you're studying information systems or security, computer security, it falls under that sort of gambit. What it actually allows you to do is allows you to verify computation of a thing without showing you any details about what was actually computed, which is extraordinary. Think of it this way. The current internet runs on a client-server model. So there's a client, your web app or something on your mobile phone, and there is a server. Now, every time you do something on your client, data is sent to the server to compute. Now, you might be wondering, my phone's become quite powerful, my laptop's quite powerful. Why don't I just compute everything here locally, especially for sensitive things? It's because the server can't trust the client. So what if you got hacked? What if something else got run and I'm being spoofed? I'd much rather run all my stuff here. Now, this is how data gets centralized. Now, all your passwords, bank account information, social security numbers are spread out all over all of these servers, all of these applications that you use, because they can't trust the client. This solves for that. Now, if I can show the server that I ran a very specific piece of code that you told me to run with my inputs, and this is the result, and you can query the result, and you can trust this information, you solved this whole problem of sending your social security numbers everywhere. This is what a lot of people call client-side proving, but that's essentially it. ZK solves that problem more generally speaking, but that's like an application of it which explains what ZK is. Now, the interesting thing is this is the most important property of ZK, but blockchain got interested for something completely different. ZK also has another interesting property called succinctness. And what that means is, let's say you ran a gigantic program. You were trying to prove that the largest known prime number is a prime number. And I ran a little program to show that 4 divided by 2 is 2. The size of the proof is the same. That means you can run arbitrarily large amount of computation, hours of it, days of it, do whatever you want, and the proof size is tiny, a few kilobytes, which fits on the blockchain. That is a great way to represent unbelievable amount of computation on chain. Whereas today, we are struggling because even by ETH's own admission, it's a Raspberry Pi. The more nodes you add on ETH doesn't become faster. It just becomes more secure. Whereas if you add more computational power running your ZK program, it actually does run faster, and the proof size is the same, and you can just submit it on chain. That completely changes the mindset of people. If you're building an application today, for example, you are bound by this scarcity of like, oh, I don't have enough compute resources. How do I make my program smaller, use less gas, do less and less? Whereas when you talk to a Web2 developer, they're not thinking about less. They're just adding more features. It's like, oh, I'm growth hacking. I'm adding more features. I want to do more things. I want to add more buttons. Or wouldn't it be great if there was an animation and did this thing and like I collected more information and I collected more data? They're thinking in terms of abundance, which is why Web2 applications are rich. Web3 applications tend not to be. Or to trade off, they do some kind of funny things to like go off chain and like get a little funky with how they manage their data and whatnot. They're cheating a little bit. So if you build something completely on chain, it is bound to have severe limitations. Those are the properties of ZK. One is privacy preserving, which is very important and is going to become, I think, the most important feature of ZK. But for on-chain applications, the succinctness is one that has captured everyone's imagination. It's something that is being capitalized right now. But over a period of time, all these features of ZK are going to come together and really sort of unshackle all the creative energy in Web3.
One of the disconnects I've had with this idea of like enabling ZK with an existing chain or like an existing L2, have other teams previously proposed building this into the stack? You would have an L2 that's a ZK EVM, whereas the technology that you've developed, you basically can, again, flip the switch and like enable this. Am I getting all of that? Is this the way to think about it? Because that's the part of it that seems so transformational to me. All of the benefits you've talked about, I thought had to be built from the ground up in a tech stack, but instead now it can be basically added on after the fact.
Yeah, I think ZK suffers from this curse of being too early all the time. And there have been several attempts at making ZK go mainstream with L2s, L1s, lots of different applications. But till the ZK VM came to be, a lot of this lived on circuits. So if I told you to write a computer program to, run a chess game, already the mind sort of starts boggling because there's there's so many rules and I need to implement all these rules. Now, if I told you, you don't write it in a high-level language, you have to put it all in like a circuit, you just not start, really. You'd just be like, yeah, this is way too complicated. A lot of the previous technologies actually used circuits or technologies that were available to them to implement some of these ideas. I don't think the idea of scaling an L1 is new. I don't think the approach of using ZK to scale an L1 is new. But the approach of using ZK VMs to scale L1s is brand new. ZK VMs, because it allows for so many developers to come in, allows for reusability and manageability of code. So if you want to sort of verify state transitions of Ethereum, that's what people mean by putting the EVM inside a ZK EVM essentially is it just proves that one state to another state was valid based on the inputs that were given. You basically take a Rust-based implementation of EVM, chuck it into a ZK EVM. It's not that simple. There's a little bit of more work to do, obviously. I would say 3 or 4 weeks worth of work. And then you can actually prove state transitions. There are independent teams out there that have taken the SVM, just put it inside RISC Zero and proven state transitions of Solana. You can do this with Move, what have you. That ability for any dev, reasonably competent dev, to pick up a state transition function, put it inside a ZK VM and prove the transitions, transforms the ability of, it completely changes who can do what, at what pace, in which chain, in which context. ZK VMs are general purpose. That is the biggest killer feature. It's you can use it in any context and still get the same performance as handwritten circuits. To be honest, we thought we'll be here in 4 years. We beat our own estimates by 3. So we are constantly pushing the boundaries of how quickly can we unleash the power of ZK. Even Ethereum, to be honest, which I think are now the really the biggest cheerleaders of ZK. I think also fair because they put in the most amount of time and mental capacity behind ZK. Even their roadmaps all assume that ZK would arrive in 2029, 2030. We will start thinking about snarkification. All that has changed. They are actually radically rewriting their roadmap to accommodate ZK as a core tenet of how they function, how they scale, how they protect themselves against quantum computing attacks, how they, build beam chains and all that stuff. So in a lot of ways, Ethereum is becoming a ZK-based chain. The other interesting thing is when RISC Zero implemented the ZK VM, because of the background that Jeremy had in open systems or open source systems, everything about our stack was open source and built on top of standards. One of the key things we chose was using RISC-V cycles, which is completely open standard. People build chips and whatever. It's a open source utility. Now Ethereum is considering changing its runtime to use RISC-V, so it becomes even easier and faster to run and verify ZK programs. That is a extremely strong signal for builders like us, as well as the market, in where we are all headed in terms of scaling Ethereum with ZK. I actually respect every single ZK project that came before us. There's too many to mention, so I'll just say all of them. They all made advancements that took a lot of effort. And this may be, the ZK VM is probably the last bit that completely unlocked everything, because it opened the floodgates for trial and error from every single team in the ecosystem. That's what you really want to see, right? If it's too hard to do, there's only 20 people who can do it. At best, you can have 20 sort of experiments going on. Now there's thousands. I can't even keep up with the BD conversations and people pinging me with like, yeah, I tried to do a thing and like, what do you think about this? What do you think about that? It's just exploding. And that's really, really happy news for all of us.
This episode is brought to you by MANTLE, pioneering a revolutionary new category called blockchain for banking by bridging TradFi and Web3 into one unified stack. With on-chain transactions, TradFi rail compatibility, and integrated DeFi features, MANTLE is reshaping how financial services work. Their flagship app UR lets users hold fiat and crypto all in one Swiss-backed account, making real-world finance usable on-chain. To learn more, go to ur.app and follow mantle_official on Twitter. Spark, one of the leading DeFi protocols, has had a year like no other, deploying $2 billion into RWAs with BlackRock's Biddle and other institutional giants, adding over $1 billion in TVL, and distributing over $9 billion across the DeFi ecosystem. Now, Spark are setting their sights on further global expansion and have introduced the Spark token, which is available on leading centralized exchanges. There's never been a better time to discover Spark, the on-chain capital allocator. Learn more at spark.fi. So there's two major advancements here that I'm like most excited to talk about. And actually, both of them do relate to Ethereum, but one of them, quantum computing, this poses a risk to all blockchains. And maybe I'm like dumbing this down too much. Please elaborate if you think there's more to know here, but quantum computing poses a threat to the cryptography that underpins blockchains. And so my understanding is that because of the speed at which quantum computers are developing, like we have to be ready earlier for a world where quantum computing exists. And so Ethereum is thinking ahead about this. I'm actually personally very worried about Bitcoin just because of the community consensus to not want to change anything, even though this is like, again, an existential risk to Bitcoin as well. So what can you tell us about like how does ZK technology help to address the risk of quantum computing?
Yeah. So interestingly, math beats math and more math beats more math. All our blockchain tech and everything is built on top of encryption, right? Like the security assumptions we make, one of the underlying assumptions is that like the algorithms used to get signatures and all these things are unbreakable or not feasible to be broken by a regular computer. You'll always hear these stats like, oh, regular computer will take like 1 trillion years or whatever, to break code. Whereas a quantum computing, because of the way it functions, it can actually traverse the possibility space much faster and figure out pairings and so on really, really quickly and break that encryption, which exposes us, across the board. To be honest, like if quantum computing is starting to break encryption, blockchain is one of many things that will break. The internet will mostly come to a halt at that point. But there are specific kinds of algorithms which even quantum computing can't really sort of get around. There are start-based encryptions. Start-based ZK proofs use hashing, which is actually quite resistant to quantum computer attacks. Which is one of the reasons why ZK is seen as, whilst I think it's like a tagline to say ZK is completely quantum resistant, that's not true. There are aspects of ZK or certain algorithms that ZK use, especially in the start space, that are very resistant to quantum attacks as far as we know. I have to add that tagline because, there's always emergent research. But as far as we know, like, they resist quantum attacks, which actually means if there is a world in which chains adopt ZK to run all their execution, their scaling, their fundamental primitives, they are securing themselves against these quantum attacks. So much so that I would say that it's not just blockchains. I also saw some news articles about the EU adopting ZK in identity management and so on. Google is pushing ZK as well for its own ID management. There is a whole world in which like every single thing on the World Wide Web starts moving towards either ZK based or using the underlying primitives that power ZK itself to rebuild the architecture. I think the next 10 years is the time frame that everyone is looking at to do all the changes. As we know, generally with humanity, we won't budge until homework is due the next morning. But I am glad to report that Ethereum is actually making considerable progress here. When we were at ETHCon, Boundless and RISC Zero was part of the conversation where we did an offsite to discuss how do we actually go from where we are to actually trying out some solutions, getting some test nets going that use ZK to really protect the network. Because these chains actually carry so many assets and so much value, it is quite important that they get their act together as quickly as possible, because we only know the progress that we know of from public companies. Where are the nation state actors? We don't know. So they might be 5-6 years ahead of Microsoft or Google, and they just don't want to publish their information. So getting there as quickly as possible is a good idea. ZK offers a easy to use, or not easy to use, well packaged solution for all of these things that can be implemented really quickly. So I'm actually pretty stoked to see ZK being integrated into the core of every chain, because that's a strong signal for us at Boundless around where we are headed as an industry.
Shiv, so something that I think about with ZK is it seems to be have so much mindshare within the crypto community and with blockchains. And, people have been kind of banging this ZK drum for a long time, but I'm curious if it's escaped outside of crypto in my little bubble to other industries, or if it's seen as important in these other industries like, AI, finance, or, something like cloud computing. Maybe you're probably best to ask, is it generating as much mind share in these other industries?
Yeah, I actually think the way to actually phrase this is that ZK kind of escaped into Web3. Most of the research up until today in ZK, including even if you account for all the hundreds of millions that Polygon put in, is dwarfed by the amount of money that Google, Microsoft, Apple, and some of these high-end finance companies have been putting into research and information systems. The funny thing is, when I was in Microsoft working on database systems, I used to work with MSR. MSR used to have an operating budget. I'm sure it's gone up beyond this. Had an operating budget of $20-30 billion. Every year, working with universities, it's one of the largest networks of privately funded research in the US in computer science, but possibly just overall. Similarly for Google. And when it comes to information security, to be honest, no one beats Apple. Apple's core premise of selling you an iPhone is we think about you when you're secure. So all these teams have been working on ZK for the longest time. You will find that when you read any paper on ZK, one or two of these authors are actually employed by Microsoft, or even if Jolt, which is A16Z's ZK VM implementation, I think some of the researchers from Microsoft. So weirdly enough, cloud computing or cloud companies have always been ahead of the research curve on this, because they know that the practical applications of ZK will enhance their own company's product suites. When you're talking about Microsoft, it's B2B. How do you protect a company's assets, information, users? How do you preserve privacy in the application that they build for retail, their version of retail? It's been very, very critical and important to them. Google, when they build Google Pay or messaging systems or email clients or cloud storage or Google Cloud Compute, how do they actually implement all of these things? So weirdly enough, I think cloud has been really thinking about this for the longest period of time. But it's always the case that even if you put in the most amount of money and time, it doesn't necessarily guarantee the breakthrough. Oddly, I think you needed to be Jeremy Brewster to actually break into building a ZK VM. There is, and I know this is a little bit of I'm just gloating about my own peer here, but because Jeremy is not a trained researcher, he's not limited by how researchers work. I say this with all the respect to the researchers, because I can't do what they do. But one of the things that they don't do well is write production quality code. They are way better at thinking about a problem to a solution, doing a proof of concept, writing a paper, submitting it, defending it, and so on. An engineer is trained to go, what is the best way to build this quickly, get it out, and make sure it doesn't fall out and scales infinitely. Jeremy is the right combination of both, and his background in mathematics, in compilers and hardware was very well suited to build the ZKVM. So the ZKVM is now, I think, entering back into the ethos of like all these companies that have been working with circuits for so long. They're like, what is this weird company that is like, doing 4 times as much ZK research as us now, because apparently they can just write Rust code, which you can just, keep in GitHub and test, and like it's all like working fine. So there's a lot of interest from cloud companies to actually adopt ZK research that we've done back into their systems. We talk to a lot of them, all the major cloud providers. We're actually across the street from Amazon. We have like my CEO and I have like chats with them once a quarter over lunch. There is a growing interest here in not just applications inside the blockchain, which they see as one opportunity, but how to actually scale their offerings and be ahead of their competition. As a cloud provider, of course, provide machines and make revenue and participate in Boundless, become a prover, all that is one thing. The other one is, how do I build a whole product suite of privacy? Because privacy is a $1 trillion market. And a lot of people want to get into it. I'm also a business guy. I'll tell you, you can't beat distribution. You have to buy distribution otherwise. And there is the days of SoftBank giving everybody $100 billion are over. So companies like Amazon, Microsoft, Google, Robinhood, TikTok is also doing ZK research. I saw a bunch of presentations from them as well. So everybody is getting into Meta. They're all getting into it. So it's going to get very, very interesting. I think I said this on stage somewhere, which is it's up to us to grow the industry. I'd rather not have 60% of a $10 million pie, but rather have 5% of a $10 billion pie. And I think the pie is growing quite aggressively, especially with the success of Boundless and proven networks, because we are actually one of the things that I realize, my personal experiences in building markets for rideshare, for Amazon, for Lyft, for Grab, which is Southeast Asian rideshare company, is the power of crypto to like turbocharge networks, to turbocharge narratives, to bring people closer to like what's going on, is untapped in a lot of ways. We have over 2,200 provers on our mainnet beta right now. That means 2,200 people have figured out how to set up hardware, connect, understand ZK, and are like doing proving. This really goes back to the Bitcoin days of like people trying to do stuff in their dormitories and stuff. This means that there is going to be more and more low-level, grassroots level adoption on like what is ZK, how is ZK useful, how is it monetized, what am I serving, what am I doing with it. This will encourage the cloud folks as well, because I do imagine smart consumers will say, isn't ZK safer and more secure? Why are you making me use a slightly less secure technology? I have a brother who's like mining ZKC right now. He tells me this is way better. The feedback will keep coming in. And just like AI, it's a juggernaut. It kind of like builds up and the momentum keeps building. It's called ZK Summer this year. So I really do hope like we have like a really strong ZK Summer.
One of the things you've mentioned is just the development of Boundless. So recently, I believe Boundless Mainnet went live in July. Can you talk to us about like what's the meaning of this? What's the significance? Actually, if you could even go back to just the basics of, what is Boundless and how does this play into all of the tech development that you've talked us through so far?
Yeah. So the ZKVM is sort of the engine, but you can't sell the engine. You need to sell the car. One thing we realized after talking to our customers, especially the most discerning of our customers like Eigenlayer and a bunch of others, we realized we needed to build a network that actually serves up ZK. We had a few choices. We could sort of like build something centralized. But to be honest, we would be personally disappointed if that's what we did. And also I think it is a foregone conclusion that like large customers don't want to take dependencies on centralized services. They want the decentralization of Ethereum baked into every product. If you are a founder listening to this, like, you should really reconsider your design. If you're, thinking about building something centralized, because the world is going decentralized, you should really, really like step ahead of the curve there. And Boundless is that. Boundless is the universal ZK protocol that is decentralized and permissionless. If you are a developer and you have a piece of program that you want to run and it costs too much to run on Ethereum, you can now, in your smart contract, call another smart contract, pay a little bit of ETH and say, like, this is as much as I'm willing to pay to run this. Here are my inputs, and I need it by 2 hours or something. This smart contract goes and talks to our network, where we have a decentralized set of provers, a permissionless set of provers who come and go as they please. And we currently have 2,200 provers on our mainnet beta. It's not mainnet, who come in, bid for this job, service the job, run the ZK program, get paid, and the proof lands on chain. As a developer, it is a perfect DevX. I don't need to know anything about ZK. I don't need to know anything about the protocol. I'm like, oh, if I ran this here, it'll cost me this much in gas. I'm willing to pay 1/20th of that. And we match you with a prover, your proof lands, you're great, everyone's happy, somebody gets paid, and you get your proof done, and you can continue with your execution. That's really the power of ZK. Now, let's say the program is gigantic. In EigenLayer's case, there are many programs that they want to run that will take 30 blocks of space, like 2 billion gas. They can't possibly fit all of that. There is no feasible mechanism to buy 20 blocks of computation. Here, they can just go offline, do it, and the proof lands on chain. It costs them like $3, $2. Currently on mainnet beta, most orders are $0. It is such a competitive market right now that the costs have gone down to zero and are staying consistently at zero, or occasionally higher than zero, and then immediately come back. One interesting thing is that when we launched our network, we actually skipped testnet. And it's a conscious decision, because we didn't want to build a network for games and just sort of fool around. We wanted to show people the power of ZK with live funds. And if you are using live funds, I'm sorry, you're not a testnet anymore. You need to be some form of mainnet. So mainnet beta made a lot of sense to us as a name. So we launched mainnet beta with live funds, and also a very interesting initiative with Ethereum, which we call the Signal. I'm happy to get into that if you want me to.
Yeah, I think I want to get into the Signal maybe just in a second here, but something that I've been kind of thinking through is something you said earlier. I think myself and probably many others thought that this kind of ZK adoption was much further into the future. And you even referenced, you thought it would take you 4 years, it took you 1 year. And I just recall everybody saying, oh yeah, ZK proving, it's not going to happen for a long time. It's too expensive, like hardware limitations, this and that. And then all of a sudden, it seems like we're in a space where this stuff's approaching this kind of almost like real-time proving. And I kind of feel like what just happened? Like, how do people almost like miss the growth trajectory of this technology so badly? I think even yourselves technically internally, right? So it's wild to see where we're at. And then, anyways, my point is in kind of like researching and trying to wrap my head around this before our podcast. I think I saw on X on Twitter somewhere that so the Boundless team delivered the world's first full Ethereum consensus proofs, and I read that and I was like, okay, I need Shiv to dumb this down for me. Like, what does that actually mean to somebody that doesn't speak whatever that language is?
Yeah, I mean, a simple way to think about this is I'll give you what people actually use right now and why a full consensus client is maybe like an upgrade. The current state of the art are light clients. Light clients are how you actually access data about a chain on another chain, or like pull out information from a chain. And the way light clients actually work is they don't try and get consensus from every single node. They randomly sample nodes and say, okay, like I'm not precise here. It's like a few hundred nodes, not like a million nodes, but a few hundred nodes. That they will sample and go like, if a few hundred nodes say this is the truth, it's probably the truth. Now, the issue with this is there is no slashing for lying. There's no economic security here. Now, to make a million nodes lie on Ethereum, you would need an infeasible amount of money. But getting a few hundred people to lie is more in the range of possible, hard, but still possible. For an important enough transaction, there is an attack vector for sure. So you're trading off trust versus convenience here. The ideal state would be if you can actually get full consensus, all the nodes agreeing on like, this is the truth, this is the state of the truth. Then and if you can put a ZK proof around it, now you can take that proof anywhere. You can carry that proof to any other chain and access full Ethereum state and verify anything and everything about Ethereum. That is the dream. Now, prior to this, there's two pieces missing. One is like somebody needs to write this client, which is any client developer on Ethereum will tell you is hard, extremely difficult because you need to really understand the internals of the client to be able to do this. The other one is the proof sizes are too huge. To run them, you need the ZK, whatever circuit or ZK VM you're using to be extremely performant. And who's going to pay for all this? This set up a stage where nobody is willing to put in the time to write something. Nobody is willing to pay for it. People who might want to like put a wall garden around it and try to become like a standard or whatever. Boundless is uniquely positioned in that we are running a prover network, which subsidizes the cost of proving because of tokenomics, because of competition and how we are set up. The ZK VM, we know, has hit a point in time when we are performant enough to take these large proofs and actually execute them. And I want to like boast about my own team. We actually have the crack team to actually write the client as well, which meant we are the right people to do it. So we built this public good. And also as a showcase of the network's resilience and strength. If you are able to do such large proofs for basically free, and you can do a lot of them simultaneously, shows a bunch of things about the network's ability to handle load and keep costs down and also deliver the proofs and deliver it in a way that is reusable for anybody who wants to build a business atop of this. And that is going to happen. In fact, it is happening. Our BD pipeline is full of people who want to use this to build DeFi products, to build bridging products. This is the fundamental building block for ZK bridging. This is ZK bridging. I can take all of Ethereum's information and bridge it over to Avalanche, to Solana, wherever. I can do the reverse as well. Once I start proving, Solana, I can take all of Solana's information and make it available on Ethereum. If you're an application developer now and you have access to the full history and state of every chain from one place using one ZKP, you have also solved the liquidity fragmentation problem. Your one application that is able to pull information across all chains without spending a single dime is able to like pull all this information together, build rich applications for you to use. The simplest way to think about this is like, let's say you're taking a mortgage out and you need to show you have X amount of money. Imagine everything is on chain. You have to do a bunch of transactions to show that you have like, 500K or 600K, so you're eligible for the loan and whatever. How would you build that on chain, like unless you actually bridge assets and like have like interchain communication really sorted out? With these kind of primitives, all of this becomes just natively available. People are able to developers are seamlessly able to like access state across chains. We actually plan to prove all the chains, build the paved path for this future, really. Again, in a sort of like Google-ish way, like the reason you build Gmail is so that more people get online. The reason why we build these public goods is like more people build a top ZK. This will drive our business. We are ultimately like trying to increase adoption, but this is a public good. Another interesting thing to consider is like when we opened this up to the community and said, what is the next chain we should prove? We got like close to 800,000. I think it's gone past $800,000 in donation to prove the next chain and so on. So the community is extremely enthused by this. And they should be. Putting in these small amounts and getting all these chains proven means better applications, better adoption. Whilst I'm not like a big advocate of like trying to, get pump bags and stuff, but the value of the ecosystem will increase when there are more applications. Some people might be motivated by that, but like overall, we're building a richer economy because of this.
Hey folks, I want to tell you about our sponsor, GEARBOX, the protocol that reimagines on-chain lending. With GEARBOX, you can access 10x credit across DeFi or lend for passive yields with single asset deposits and no impermanent loss. Users can access leverage to margin trade, stake, farm, and more. To learn more about GEARBOX, go to gearbox.fi. Rumple Labs is revolutionizing DeFi. Rumple lets you turn points into profits By tokenizing rewards, you can trade from top protocols like Pendle, Athena, Fluid, Symbiotic, and many others. No more waiting for airdrops or TGEs. DeFi's smartest investors are already using Rumple to unlock instant liquidity and maximize their yields. So join Rumple today and start spinning your points into gold. Learn more at rumple.xyz. Puffer Institutional delivers secure, high-yield Ethereum staking built for institutions with battle-tested security, granular access controls, and the ability to boost APY by securing multiple AVSs. Puffer gives institutions full control and optimized returns. Puffer is also behind the Unify-based rollup, aiming to transform Ethereum's future in a world where all L2s are working together. To learn more, go to institutional.puffer.fi. Shiv, how does this change or improve the DeFi user experience for us? Can you paint a picture of what might change in the future? You mentioned liquidity fragmentation is essentially solved by this, which is absolutely still a pain point for folks that, want to use DeFi and move their liquidity from, one L2 to another. So anyways, whatever you can do to kind of bring that to life for us.
I think you hit the nail on the hammer on the nail. I think that was right. It's if you want to move assets around, if you want to do something on one chain, leave assets on another chain, play around with another app on another chain, there is a very confusing setup that we have to navigate these days. Oh, my USDC is on base and I need to do a thing. I need to pay for that. So I need to bridge over. There's this whole mental model of things you need to do. Not to mention, if you are someone who's not staying atop of what is the latest and greatest tools, you might actually be paying more because you're using some outdated protocol or something like that. Whereas, what is the experience that we are most comfortable with, or we've learned to use in Web 2? I just fire up Fidelity, or if you're using some kind of finance app like Mint or something like that, you just fire it up. It has access to all your financial details across platforms, across banks, across institutions, and your people can build just stuff on top. Credit card companies can pull information about you and give you a credit score and do all these interesting things based on which you can apply for loans. You are not used to really thinking about which ledger is my bank account information really stored on, right? That's not even a concept that people have. In fact, most people don't even realize that their bank is just basically a ledger. But you just completely just live life as completely ignorant of all of these things. You go to France, you swipe out your credit card, everything just works. You don't really know that there was a Swift transaction or something else. You live in complete ignorance of all of these things. And that's great. Why should you know all these things? But in Web3, there is a really high barrier to be a multi-chain player. Because you're I'll just, I don't want to mess with all this. How about I just keep everything on ETH? Isn't that better? Yeah, but also you're paying quite a lot on gas. Maybe you want to move to an L2. This allows for this sort of evening out of what settlement layer you use. It's completely an opaque layer to you, because applications are able to access state from any chain. Right now, our focus is EVM-based chains, but we're really working hard to make sure we have access to all the major chains. And at which point, your data could live on some chain. Not data. Your assets can live on some chain. Maybe you're using an application on a completely different chain, and you don't really need to know this. And they have access to all of your information because signal proofs are available on whatever chain your application is acting on. You're able to transact. Everything is great. They're this is cool. So from the real perspective that our moms and dads really want to have is I have money on chain. Which chain? I don't know. I have money on chain. I used it to do this. Cool. That's the limit of information that really users want to have. We are because of the way we are architected, confusing them by talking about L2s, L3s, L1s, alt L1s, DAs, roll-ups. They're all what? Do I have my money on chain or not? And the answer is yes. Here you go. An application that shows that you have money on chain and you want to take a loan out. Cool. You've taken the loan out. Great. Good for you. And stuff just works. This sort of interop layer, actual ZK bridging allows for this future. We really foresee a lot more interesting applications coming out of this as well. Something that I don't even believe like you and I in this podcast will be able to imagine. And that's good. Like our imagination should not be the limit of what can be built. What we build right now is basically limited by what's possible on chain. This unlocks access to information. Any finance guy will tell you the more information you have, the faster liquidity moves. The more money, the more opportunities, the faster the price grows and everything. So we really want to like unleash that for the ecosystem.
What we talked about earlier, I remember like the EF came out like, holy shit, like we can actually use ZK way sooner than we thought as well. And then I know they were going down the road. It almost looked like they were going to enshrine like RISC Zero to some degree. And then I thought I remembered a bunch of other, maybe call them competitors, came out of the woodwork. And like, I think Succinct was one of them. And like, I kind of want to know where we're at with that. Like, is the EF picking you guys? Will it be Boundless tech that scales Ethereum L1? Like, can you answer that sort of like point blank?
I'll answer that. I'll also give some context here. 2 years ago, there was only one ZK VM, RISC Zero. And something like 18 months ago, there were two. Succinct shows up. Today, there's 40. A lot of people like to frame this as, oh my God, now you have competition. And I go, oh my God, now we have competition, which is good. Now, the other interesting thing is 30 of those 40 ZK VMs look almost exactly like RISC Zero. That's because we built the standard. Building standards is important. Adopting standards is easier. We paved the path. A lot of people are now coming in. They're trying more interesting ideas. They're trying to experiment with different ways of building more valuable ZK VMs. We actually appreciate that. We laud them. We're very good friends with nearly all of them. Because, we want to do core research. Like, we don't want any security issues, soundness bugs. We work with each other. We share information. We give out expertise freely to help all these companies, come together. One of the big reasons for that is we knew that building a completely open source ZK VM has no moat. We wanted people to actually use our code properly, responsibly, but definitely as much as they can. So we're really happy to see this. The interesting thing about building a proven network like Boundless is that we actually see this as a way to funnel in more ZK innovation as well. One of the key things that you may have noticed earlier as well when I was explaining the relationship between RISC Zero and Boundless is the founders are staying at RISC Zero. They're going to go deeper and deeper into research. I'm positioned in Boundless to focus on growth, to focus on including more and more ZK research that includes more ZK VMs as well. Boundless is not a single innovation or a single engine car. We want to put in more ZK VMs, more interesting ZK VMs doing different things coming in so that as a customer, you're able to pick and choose what you want. Maybe there's a ZK ML is like an interesting side area of research. ZK focused on machine learning and AI is a side sort of functionality which is like growing. There will be at some point something new and radical there, which a general purpose ZK VM might be not best suited for. So we want to make sure that's available on Boundless as well. So we are actually like really focusing on growing the market and so on. I will say we are actually very happy to see other ZK teams succeed as well. Because two things happen. Education, more people know about ZK. And there is also a paved path approach. More people know, more people adopt, then they get an option of picking and choosing what they want and the best option. We believe that's RISC Zero because of our background, our open sourceness, and so on. The last thing I'll say is like, if you actually listen to Justin Drake, who is the core researcher at Ethereum Foundation, and possibly the one driving all the ZK efforts at Ethereum, alongside Vitalik, who posts a lot of information on his blogs and so on. His sort of like categories for enshrining a ZK VM are as follows. Must be completely open source. We are completely open source. Must be fully formally verified. We are on that path. A lot of teams are not. Not are all the teams open source. Must be available in a permissionless setup. Easy to access. That's Boundless. In a lot of ways, we are satisfying the goals of Ethereum in building that like perfect ZK product that is available to them. To enshrine one ZK VM is going to take 3 to 4 years for them. Because that basically means the entire setup of Ethereum, all, $800 billion or $1 trillion on assets are all built atop of one piece of technology. So I don't think they should make that choice hastily, and I don't think they will. They will let the technology bake for a while, and that's fine. We want the technology to bake as well. just like a lot of your listeners, I also hold some bags on Ethereum. I would really not like to have a bug in that, please. So it is important to go through that journey safely and securely until enshrinement happens. But that doesn't mean ZK VMs are not ready. All it means is like you don't want to take a complete dependency on just one piece of tech yet. The approach that a lot of people are going to be taking for the next 2 or 3 years is like a multi-ZK VM approach. It's like, oh, how do I get proofs from two systems if my system is too critical? And Boundless is uniquely positioned to serve all of that as well. So that's like the real sort of straightforward answer. I think Ethereum is, or the foundation is extremely focused on this right now because they know. So here's a very honest take. They put like a hilarious amount of investment in ZK. Everything is open source. They can easily be overtaken by someone else adopting ZK faster. If a lot of chains out there just don't have any execution layer, we are the execution layer. ZK is the execution layer of blockchains. They just adopt ZK and they can leapfrog Ethereum in a real business kind of way. So there is a sense of urgency, I think, with the Ethereum Foundation as well in like investing in aligning on goals, in making sure the roadmaps are well aligned and so on. This will all bear fruit, in my opinion. I think we are extremely strongly positioned to be one of the key pieces of Ethereum's roadmap. I don't even know if they need all this enshrinement business, to be honest, because the way everything is headed, we might just scale Ethereum to a point where they might punt on enshrinement. Because ultimately you need to be driven by your builders and your users. And what they're really, really clamoring for is applications. More applications, more utility. And that is something ZK just unlocks natively. So if they actually get to a space where like there's lots of applications, everything's going fine, you shouldn't do more than is necessary. You should focus on what your users need. They just need more and more. They need a lot more block space, and they need a lot more computation. And then I think you just leave it to the creatives to build like great applications for people, whether it's in DeFi, gaming, NFTs, art, culture, social networks, whatever, what have you. Unleash that and actually like build that app store. Like you need that crazy app store where you can just go and like get any app you want and run your life on chain.
By the way, Shiv, the term enshrine gets thrown around a lot. I guess like what does that exactly mean? Enshrine, like what goes into that? Because it seems like a pretty big deal if Ethereum were to do this.
Yeah, so if Ethereum enshrines anything, to be honest, it means it picks a technology, assumes that this is the core piece and will never change, will make assumptions about that technology and build around it. So in a lot of ways, you not only become essential to the running of Ethereum, you move away from becoming like a vendor or a piece of tech that they use or a tool or something like that to like something that is internal and is used in every single thing, every single distribution. People need to understand what it is. It is managed, funded, like there is a long-term play here. Enshrinement is something that like everyone tries to avoid for as long as possible, because it basically means you're picking a thing forever, and you're kind of stuck with it, is what the engineer would say, because eventually technology does become older and staler. What you'd much rather do, so this used to happen, by the way, pre-cloud, when you were running stuff in data centers, because you need to buy machines, and machines run for 6 years at least. So you would enshrine a vendor, you would enshrine a piece of tech, you would enshrine something because this gives you fixed OpEx and all that. And the cloud completely flipped the narrative and said like, you can upgrade to the latest and greatest as we swap shit out. So basically you pay a slightly more on OpEx, but you get this amazing flexibility because you're able to offer so many more interesting things to your customers. Imagine if Netflix was like, oh, this is all the capacity I have, so no more shows, guys, or limit the streaming or some stupid shit. You just stop paying $20 a month. So the cloud actually enabled that. So in a lot of ways, enshrinement is, as an engineering principle, is sort of avoided on things that you can avoid. But enshrinement also makes things more tighter coupling. A good example of this is Apple, which is a fully integrated stack. They control every single piece of the hardware, and they're tighter. So they build, I would like to say better hardware for retail computing users. But then again, you can't swap shit out. You're stuck with whatever you have. This is it. This is and that actually, like, if you're an engineer, kind of makes you a little bit uncomfortable. It's like, oh, I can't use this and I can't use that, and which is why a lot of people, prefer Linux and whatever. So that is the real sort of play here with enshrinement. I think if you have a fully formally verified ZK VM that is extremely performant, has all the ability to sort of prove Ethereum on a single machine at low cost. I think they have some, they want basically to be able to prove Ethereum in your house. So the regular power supply. So there is a concept that I do feel like the goalpost will be moved as we progress as well. So simple hardware that you can buy, run in your home, prove Ethereum. That's really the goal that they're driving, which is great. Once that happens, it becomes a question of, so I would also assume that there will be multiple ZK VMs trying to chase this. So what if you have multiple ZK VMs that are open source? You'll move the goalpost to like find like what is the next best thing and the next best thing, which I think is just generally good. I actually don't think it is in Ethereum's best interest to enshrine something. Historically, that has slowed them down or slows projects down. I have a feeling it'll slow them down as well. They have just come out of a phase where people have been criticizing them for like being slow in product development. I think they should learn their lesson and just not go after that, but like have this competitive marketplace between ZK Tech ongoing. It will continue to reduce prices, increase performance. Let the markets play out, and you will see much better outcomes. I don't think there's any need to put, pick a winner or whatever. Like historically, has never worked out for anybody. And that has actually been one of the reasons why ZK has out-delivered on its promises, because market forces have run rampant. Something that like I feel like somebody who's interested in finance will understand a little bit better here is like if you actually look at AWS's earnings and look at the gross margins in AWS by different sectors, you will see the database products, the settlement layer of AWS, if you will, comes out around 8 or 10% of the entire earnings and at a gross margin of like 30-35%. EC2, which is the compute cluster, is 50-55% of all the revenue at like 50-60% gross margins. Interesting to note, databases inside AWS actually run on EC2 as well. Sort of like how EC2 also runs on ZK. Ethereum also runs on ZK. ZK represents the compute layer. So the thing to actually remember here, take from that is like the market for ZK is 4-5 times larger than the market for settlement. And if you ever manage applications in a large company, you realize that is true, because when you actually get the bill from AWS, most of your money just keeps going to where the application scales, which is compute. When Lyft or like rideshare, 10x is in volume, you go 20x in like your containers and all of that. Your database usage doesn't scale that way. Most of the data is just reads. So you cache a bunch of that shit and like whatever, right? So if that happens, means there is a lot more money to be made in ZK, which is part of the reason why there is so much activity in ZK. I would like to imagine everybody is altruistic, but nothing moves the needle like incentives. And the incentives here are to build a completely, 10x execution layer for all Web3. That's the opportunity that Boundless is chasing, which makes us extremely energized, of course, that we're chasing something so big in scope and vision. So yeah, that's part of the reason why like there's so much interest in ZK as well. People see it as something that is going to be 5 to 10x bigger than just blockchain itself, in terms of just not just earning opportunity, but also just market size.
I want to go back to something you said. It was probably about 20 minutes ago when you mentioned the signal, and then I think we asked you like 5 different questions, kind of got off topic a bit, but I want to go back to that because I want you to kind of just define what that is and how that ties into Boundless.
Yeah, so Boundless, of course, is the universal ZK protocol, right? So what we can do is take arbitrary amounts of compute requests, run them inside a ZK context, and serve them to you. One of the biggest problems or promises, I guess, of ZK has been things like ZK bridging or solving interop essentially between chains. The signal is our first step towards both doing this as well as showcasing the power of Boundless in solving this problem. Signal essentially is proving full Ethereum consensus versus sort of just, when a lot of people talk about proving Ethereum, they mean, proving state transitions. Proving full consensus is a completely different thing. That means actually showing consensus between all the nodes in Ethereum that this is the state that you can actually trust. And packaging all of that inside one ZK proof that you can take with you to any chain, any application, unwrap it and verify all the state of Ethereum and verify it. So if I want to take my assets on Ethereum and make them available in Solana for some different application, there's stuff that I need to do as a user. Whereas if all the state of Ethereum is now available in Solana, any developer can access it and do whatever they need. You don't, as a user, you just don't need to do anything. You're just running your application on Solana, which somehow magically has access to all the information on Ethereum, is able to access that information personalized to you, run some, application logic, make you a very, very satisfied user. Now, the goal with Signal is not to just start and stop with Ethereum, but to start with Ethereum and then move on to every single chain. Once you start doing that, really the interop problem really goes away. We plan to do that as a public good, work with lots of partners on our end to build applications on top. We are already en route towards that. And hopefully by the end of this year or early next year, you start seeing more and more applications built atop this initiative that start hitting users and give a much richer user experience.
So Shiv, with all that you shared, I know you've kind of created the standard for a lot of this, and it's a lot of this I think is open source. So I'm always curious how you defend all the work that you've created, almost maybe how do you monetize it yourself, and again, how do you what is the moat around your creation here at Boundless too?
Yeah, that's a great question. So another way to phrase this is what's stopping someone from the street coming in and saying oh, I'll just take RISC Zero, it's completely open source, and I'll put it together with some supply, and bam, I have a market.
I will say there's a lot stopping me personally from doing that, and it's because I don't understand any of it.
Okay, then that's one less person I need to worry about. But to be honest, we weren't just building a marketplace. One thing that we wanted to really do is innovate on the marketplace as well. One thing I'm a strong believer in is if you don't innovate at every level, you will be left out. And you will be in this new world that we're living in, especially if you're a startup. If you start resting on laurels and all of that, you'll be left behind in no time. So instead of just building a marketplace for ZK proofs, we wanted to build a ZK-powered marketplace. What that means is the marketplace is actually very aware of what it is that is being bought and sold, and how do we actually take advantage of that. So on the supply side, so let me just take a step back. A lot of people think all marketplaces are two-sided. They're mostly right, but it is always driven by one side. For Lyft, Uber, Grab, these sort of rideshare cases, it's a two-sided marketplace, but it's supply-driven. The reason for that is the cost of acquisition and the lifetime value of supply or drivers is much higher. It's harder to get drivers. It's easier to get people who want rides. There's quite a lot of them, millions of them actually. There's only so many thousand drivers. So it's the same case here as well. It is a supply-driven market. If you can get a lot of supply, it drives the cost of demand down, and then you can get more people to use the ZK proofs at this lower price, and that kickstarts the cycle. All that said, that means that on the supply side, we want it to be as complete of a stack as we possibly can, as open source, and as innovative as we could as well. So the first thing is that we actually built this entire open source stack for them. It's it comes with two pieces of software alongside the ZK VM. It's called Bento and Bonsai. Bento and Broker. Broker talks to the market. Bento allows you to manage a fleet of GPUs. This is, you might think it's a table stakes thing. It's extremely hard to do. to build something and give it away and say like, now bring thousands of GPUs and we will help you manage them effectively across your data center, and we will help you like process, thousands of dollars, millions of dollars worth of like ZK proofs. We build that, we give it to you. If you are, participating in our network, you get it for completely free from us. We also encourage people to take it, rip it apart, and build something better. Go for it, right? Have fun. The other thing is there's a key primitive in our network which is called proof of verifiable work. People are familiar with proof of work, Satoshi's original innovation. Whilst there's not a lot to criticize about proof of work, there is one, which is it is energy inefficient. You do end up wasting quite a lot of energy doing computation, and every epoch only has one winner. So we're all chasing to find this like key hash that gives us these, leading zeros and whatever to win the epoch and win the reward, as it were. What the power of ZK actually allows us to do, and this is like, again, like a key feature of ZK, is every time there is a proof generated on Boundless, the proof system attaches metadata, cryptographically secure metadata about the number of cycles of work you did. Remember when I told you could actually do like a hilariously large computation or a small computation, the proof size is the same? Another way to look at it is that the proof size completely masks out how much work you've done. So there is no way to know how many cycles of proving you've actually done unless this proof itself contains some kind of metadata that is unalterable and gives you some indication of how much work you've done. So on Boundless, at the end of every epoch, we can actually tally up how much work everybody has done and reward everybody in proportion to the work that you've done. So if you were a Bitcoin miner and you wanted to apply the same logic here, if like 1 million people tried to mine this Bitcoin and one of you is a college student and you only have one machine, I have 500 machines, I've done 500x the work that you've done. In the Bitcoin world, the probability that I'll take most of the rewards is very high. You will get nothing. There's no point in even participating. But in our world, I would get 500 times the reward that you would get, but you would also get something. This makes it a completely sort of equitable distribution of rewards based on the amount of work that you do. Again, I'll go back to Justin Drake, who is the EF researcher. He also pointed this out, that like as we start building out more prover networks, this is probably the state that we want to be in. Not like not like MEVs where everybody's sort of chasing each other and like wasting computation, but rather a cooperative settlement where everybody who does work is able to get rewarded. That will really increase the size of the pie. This innovation on our end solves for so many things. Allows us to like onboard supply really fast because of the stack that we built. They are hardwired to like start making money from day one. They are hardwired to like service orders. Even if they start with a smaller rig or a smaller setup, they can scale up, allowing them to actually build a business as a ZK prover. I really do want to make sure that our ecosystem supports sustainable businesses. So from my perspective, one thing that we modeled out is if you are somebody who's trying to become a prover and this is your business model, how would you what is the initial investment you need to make? What is your OPEX, CAPEX, and how would you scale? And we have all of this, really sort of mapped out. And we think proof of verifiable work is one of the key things that differentiates us from every other sort of marketplace that you can conceive. The last thing I'll say is we have a reverse Dutch auction for, figuring out who should do the proofs and all this bidding and all of this stuff as well, which is one thing we wanted to test on mainnet beta to see how well it would subsidize the cost of proving. We're seeing 99% discounts on all proving. It's actually 99 point something. So basically zero. You're paying nothing for your proofs, which means the market is really, really functioning. So yeah, that is the moat. The way to defend this moat is continued innovation. There is no pause. And that is something we want to keep. The pace of ZK is also something that we want to adopt in Boundless, and the pace of market innovation as well. I was there when Grab and Lyft were fighting Uber with Travis Kalanick. I want to bring back those days because what it actually did was completely changed everybody's perspective on should I buy a car? For a period of time, people were buying cars won't be a thing. I want to make sure we bring back that sort of mentality and really build a flywheel here. So yeah, that's the moat.
With everything we've discussed, I must ask, is there a token coming?
Yeah, so the Boundless network is powered by ZK Coin, which is the token that is used to incentivize proving, and also used as collateral for provers to make sure they stick to the deadlines and stick to the promises that they make to people when they take up a job. That will be launching alongside our mainnet, which we expect to be in a matter of weeks, not months. The whole point of having a mainnet beta is to also signal to the market that like mainnet is not too far off. We expect to be technically ready soon, test out some of the edge cases, make sure we iron any of the glitches. And there are a few. I will openly admit, like when you launch something, it's like there's lots of weird things that you don't expect. And whilst everything looks very calm in crypto Twitter and we're all like presenting a nice smiling face, there are always like things on the back end where we're like, oh yeah, that we didn't expect that to happen, or shit, that fell over. Oh, we never expected the scale, and like fixing all of these things. That's going to be an ongoing process. But we should be ready in a matter of weeks.
Well, guys, I think this is a great place for us to start to wrap up. So I want to remind our listeners they can first learn more about RISC Zero by going to risczero.com. They can learn about Boundless by going to beboundless.xyz. They should follow RISC Zero on X or Twitter, follow Boundless_XYZ, and then follow Shiv's personal account. It's SSH_NKAR, and we'll put that into the show notes so you can easily reference it. I hope folks enjoy this episode. I think that what you all are working on is very important to ZKifying, every L1, every L2, every sort of network. But there's also a promise of working with even the Web2 world as well. We really appreciate you coming on to the show. Thank you so much for your time, Shiv. And just want to give you the final word.
Thank you. Thank you so much for having me. I hope you and your listeners follow along with us as we try and change everything for the better. I know ZK can be a little bit scary or whatever. Like I try to make it fun. So does my team. We're happy to answer questions on Twitter. We love doing that as well. So yeah.
Thanks everyone for tuning in. To stay up to date with future episodes, plus get expert tips, strategies, and exclusive content, subscribe to our free newsletter at the-edge.xyz.